This is an introductory video, so let me first introduce the project. The DOTS Traffic Core is a powerful tool for creating massive city traffic based on the Unity DOTS Entities package. With this asset, you can build your own high-performance games for both PC and mobile devices. This comprehensive, all-in-one tutorial will guide you step by step through the entire setup process, from installation to a fully working environment. First, you need to install the necessary core packages. Upon importing the asset, the package installer window will appear automatically, but you can also open it at any time from the top menu. Click the Load Packages button to start downloading the required dependencies. If you want to learn more about these packages, you can always check the official documentation. Once the download is complete, the main .city scripting define symbols will be added to your project automatically. Now, it's time to add the initial components to your scene. Go to the top menu, select the Spirit 604 tab, open the City Editor, navigate to Create, and click City Base. Next, select your world simulation type, DOTS or Mono. DOTS runs the traffic and pedestrian simulation entirely in the DOTS space. In contrast, Hybrid Mono runs the physics simulation on Mono behavior scripts while taking input from the DOTS entity simulation. Then, depending on your specific use case, select the entity type for traffic. Press the Create button. After that, drag and drop the test camera into the scene. Make sure your camera contains a cull point object. Note that a cull point is generated automatically during HUG creation. If a camera is already present in the scene, the cull point will be automatically created as its child object. In our case, we can delete the extra cull point from the scene because our test camera already has one. Finally, select the hub base object in the hierarchy and click Generate in the inspector to create a new subscene. And that's all you need to get started with the initial setup. Now, let's move on to the next steps, where we will configure the traffic nodes, set up the roads, and bring our city simulation to life. In this section, we will add cars from scratch. First of all, we should adjust the vehicle prefabs to ensure they drive correctly on the ground surface. Select your road in the scene. This can be a flat surface collider or, in our case, the road mesh itself. As you can see, the road is assigned to the ground layer. Open the Hybrid Traffic Car Monoskin Base Arcade prefab for mono behavior vehicles, and ensure that the raycast layer matches the ground layer. Do the same for the DOTS prefab if you plan to use DOTS cars. Open the Entity Custom Physics Base prefab and verify that the cast layer is set to ground. There is no name displayed, but the layer index must match the index of the ground layer, which is 18 in our case. Next, we need to open the Car Prefab Creator window to generate our vehicle prefabs. Drag and drop your desired vehicle prefabs into the window, and then click the Scan button. Next, open the Save Settings tab. Here, we need to configure our preset parameters. Set the entity type. In our case, let's select Hybrid Mono Physics, which will work perfectly with our mono behavior world setup. Keep in mind that for mono behavior cars, you should select the Hybrid Mono simulation type in the general settings. Conversely, for DOTS cars, you need to select the DOTS World Simulation type. Also, note that when working with DOTS cars, you must specify which exact DOTS car you want to use inside the traffic settings. Additionally, before generating the subscene for DOTS vehicles, you will need to enable the Copy Physics Shape option inside the hub object, selecting your designated ground layer. This ensures the ground collider is cloned into the subscene, giving the DOTS cars a physical surface to drive on. As you can see, the subscene was successfully generated and the physical colliders were cloned. Since we are creating a mono behavior car, let's switch back to the mono simulation type. Let's go back to the Car Prefab Creator. After that, specify your save path and press the Create button again to finalize the preset. Now, let's experiment with the prefab we just created. Check the Allow Override box so we can modify the prefab during creation. Drag and drop the newly created prefab into the scene. Next, open the Additional Settings tab. Let's enter a new wheel offset value and click the arrow button to apply the setting. Now, press Create again. As you can see, the wheels has moved along the y-axis. Let's also experiment with the local offset and recreate the cars. Using this workflow, you can quickly override settings and experiment with different parameters on the fly. In the Prefab tab, you can specify parameters specific to the desired vehicle. Moving on to the Graphics tab, you can select the Wheel Sharing option. This allows all wheels to share the same model, significantly reducing memory overhead and draw call usage. Now, let's locate our created preset. Find the traffic baker reference in the scene to check our results. Next, locate it inside the subscene as well, and make sure that both presets match. You can manually synchronize these presets in the inspector using the Sync to Subscene button, or you can just apply a prefab for the edits. Alternatively, you can instantly sync all presets and configs at once via the main hub. With that, we have successfully created our first mono vehicle. Let's launch the scene and see it in action. In this section, we have learned how to create both mono and dots vehicles from scratch. Now that our core vehicle prefabs are ready, let's move right into the next step, where I will show you how to customize and fine-tune the advanced physics settings for your dots cars. This scene is specifically designed for customizing custom physics cars. First, select the vehicle custom spawner and choose your spawn type, either player or traffic. Next, open the subscene and select the vehicle collection to view your vehicle presets. To speed things up, you can also directly drag and drop any car you want into the subscene without using presets at all. Let's open the player vehicle prefab. First, set the origin move type according to your needs. Then, adjust the initial position of the suspension and the alignment of the wheels by dragging the green arrow in the scene view. Don't forget to set the correct wheel radius and width. Finally, configure the cast type and cast layer. As always, you can read more about these specific parameters in the official documentation. Now, let's launch the scene and see it in action. You can press the tab or arrow keys to instantly change your test location. Let's open the vehicle prefab during runtime to experiment with different parameters. Remember to save your prefab after making changes, and then press the backspace key to reset. Let's pass an obstacle. You can hold the left mouse button and move the cursor to change your camera view. Now, let's change the suspension length and pass the obstacle again. Next, let's tweak the mass and stiffness. As you can see, the car starts to jump. Parameters like stiffness, damping, vehicle mass, and the apply impulse offset can all drastically affect this behavior. The apply impulse offset calculates forces from the contact point of the wheel. It's crucial to ensure that this offset and the vehicle's center of gravity are close to each other. If the center of gravity is too low, the car will almost never flip over, but the body and suspension will feel less stable. If it's perfectly in the center of the car, it will behave much more like a real vehicle. Let's reset the parameters and set the apply impulse offset back to 0. Taking a little drive now, the car starts to roll on its side. That's because the center of gravity is low, while the apply impulse is set too high. Moving on, let's look at the custom steering limit parameter, which sets the steering angle relative to your current speed. Currently, with it disabled, the car turns instantly at any speed. To fix this, enable custom steering limit and set the limits according to your speed in meters per second. Now, let's head over to the ramp and press space. The transient force parameter is responsible for holding the vehicle steady on an incline. Watch what happens when we disable forward transient force. The car instantly starts to roll down the ramp. The same applies to lateral movement, so ensuring you have enough lateral friction and lateral transient force is key. Press the tab key again to change locations and take a final test run to see how the car handles. You can also press the F1 key or click the car icon to instantly switch to another vehicle. Any DOTS vehicle in your project can be customized using this exact same workflow. Now that our vehicles and custom physics are perfectly dialed in, let's move right into the next section of our guide. In this section, we'll create a simple road network. First, we need to set up the initial components. Select the desired world simulation and entity types. Generate a subscene using the hub object. Press Move Back to return the road route to the main scene. Now, we can build a simple intersection. In the Unity toolbar at the top, navigate to 604 Spirit, City Editor, Create, and select Road Segment. Enable the Position Handle option along with snapping, since our map is based on a grid. Set the lane width and the intersection width. Each segment has its own custom settings. In this case, we can configure 3 or 4 sides. Next, duplicate the segment we just created. Copy the segments by pressing Ctrl-D and place them according to the road. Open Path Settings. We can change the speed limit and relocate the waypoints. Drag the position handle to adjust the path's trajectory. In the Custom Settings, select 3 sides. Press the Caps Lock key to rotate the segment. Now, let's create a turning segment. Adjust the crossroad width according to the road. After placing all the segments based on the grid, we need to connect them. Open the road parent object. Press Force Connect. Once the path is generated, click Bake Path Data to verify that the structure is built correctly and to bake the data. Open the hub object and regenerate the scene. We have successfully created a simple scene. In the next section, I'll show you how to build an advanced road network. In this section, we'll focus on creating an advanced road network. We will start building the scene by creating a custom straight road, which is designed to form straight roads of any shape. Place it roughly where it should be located. Align the nodes so that they run along our road layout. Set the lane width and the divider width so that the tracks align perfectly. Now that the nodes are positioned correctly, start extending the road by holding down the left Shift key and clicking the left mouse button. As you can see, we have accidentally selected the ground. Let's lock it. Let's continue extending the road by holding down left Shift key and clicking the left mouse button. After placing all the path nodes, begin aligning them by location and rotation to perfectly match the road geometry. Once you have finished the segment, you can set a speed limit for it in the path settings. Create all the straight paths at this intersection in the exact same way. With all the straight paths ready, we need to construct an intersection. Create a custom segment. In the Advanced settings, select Intersection Creation. Select the nodes of all direct paths present in the scene. Press the Create button. That was the first method for creating an intersection. Now, I'll show you the second way to build them. Create another custom segment. Set the lane width and divider width to match the existing road in the scene. Arrange the nodes on the scene according to the layout of the roads. Enable Customize Nodes and create the third missing node. The nodes must be positioned so that the white arrows point away from the center of the intersection. Click the Open Traffic Node Editor button. Here you can customize each node individually, then click Set Settings. After placing the nodes, select Auto Crossroad in the additional settings. Press the Create button. Now let's add some additional paths. Open the Path Creator tool. Select the nodes between which you want to create a path. Choose the lane indices for which you want to generate a path. When the green path preview appears, it means it's ready to be created. Press the Create button. After finishing the scene layout, click Bake Data in the road parent. The console will show warnings indicating that some traffic nodes have empty left lanes. Let's locate them. Open the Traffic Object Finder tool. Find the problematic nodes using their unique instance IDs. Fix them according to the instructions in the console message. In this specific case, there's nothing to do. You just need to complete the road network so there are no dead ends. Once you have finished creating the scene, click Generate Subscene in the hub object. Now, click Move Back on the hub object to continue working on the road. Let's convert a regular segment into a custom one that will be positioned on the bridge. Disable the lights in the Lights tab, as we are going to use the Scene traffic light instead. Adjust the crossroad width to perfectly fit the intersection. Create a merge crossroad leading to a one-way road. Press Flip Sub-Lane Node. Set 2 lanes for the one-way side. Switch the one-way direction. Adjust the crossroad width and sub-lane distance to fit that specific intersection. In the other settings, press Convert to Custom. From this point on, this segment becomes a custom one. In the Snap settings, press the Snap to Surface button to align all objects of the segment to the bridge surface. Now, let's build an access ramp to the bridge. Create a custom straight road. Move one of the nodes to merge it with the existing intersection. Place another node at the entrance of the ramp. Set the lane count to 2 and tick the one-way option. In the Path settings, tick the Path Handles and Buttons option. We can now add an inner waypoint along the ramp by pressing the plus button directly in the scene view. Move the newly created waypoint according to the curvature of the ramp. After that, in the Snap settings, snap the road along the ramp surface. Readjust the waypoint position if necessary, and snap it again. Now, you have learned the common principles of how to create most road types. Let's move on to creating a traffic light. Let's open the traffic light prefab in the scene. Add the traffic light object and traffic light object authoring components. Now, let's start creating the light frames. Let's create an empty game object and add a traffic light frame component to it. Let's create a traffic light object specifically for a pedestrian traffic light. Now, let's assign the traffic light signals to the traffic light frame. We'll assign an index direction to the pedestrian frame so that the raycast originates from it correctly. Now, let's open the traffic light's parent object and click Assign Initial Child. Let's remove the pedestrian traffic light from this list because it has its own dedicated traffic light object. By default, the traffic light index is automatically assigned to -1, so let's change it to 0. Let's do the exact same for the pedestrian traffic light. Let's open the traffic light's global settings. As you can see, we're getting a Crossroads Not Found message because the roads are currently closed inside the subscene. Open the hub object and click Move Back. Let's open the traffic light's global settings again. Unfold the Auto Light Connector tab. Click Reconnect Lights to automatically connect all the lights in the scene based on their positions. As you can see, the number of reconnected lights is 0 because they were already connected. Untick the Connect Only Missing option and try again. This way, we automatically connected all the traffic lights on scene. There's one more thing. If you're using dot simulation and want to use traffic lights in the main scene, you need to enable the Is Active option in the traffic light hybrid service. For mono simulation, this service is enabled by default. In this section, we will do a complete overview of how to set up traffic lights and configure their timings. The Global Light Settings window allows you to connect any object to a traffic light or modify the traffic light timings for any segment. Now, we can connect the created traffic lights. Select the desired light handler. By default, each segment contains 2 handlers. Then, select the target traffic light. And that's it. The traffic lights are now connected. This method allows you to connect traffic lights, traffic nodes. Let's observe the scene layout. This tool displays the traffic light settings for each individual segment. You can also see which traffic lights have been turned off. In this menu, you can replace the global light settings for specific segments. Press the asterisk button, select the new settings, and click Replace. We can also select other light connection types. Traffic node. This allows you to change the connection between traffic lights and scene objects. Let's return to the previously created segment. Select the traffic light crossroad component to modify the traffic light timings. By default, the The timings are managed by a shared configuration file. To set custom timings, enable the Custom Settings option. Add the desired states using the plus button. Customize the timings according to your preferences. Add and configure the remaining states. Next, we can loop the timings for another light handler. Press the Loop Time Settings button. Select the Source Data Handler Index, which equals 0 in our case. After that, select the destination traffic light by pressing this button. Click the Loop Time button. Now, the second traffic light handler with index 1 has a looped timing synced to the first handler. We can also create a custom traffic light handler for a specific path. Enable the Custom Arrow Settings option. Select the desired traffic node. Select the target path. The selected path is now highlighted here. Press the Add Custom Light button. The arrow light handler will now appear in the list of handlers. Here, select the related traffic light handler and adjust the light duration. To remove the newly added arrow light handler, simply press the Remove Selected Path button. Now, we can learn how to manually assign the lights to the road objects.